All right, so here we go, guys. So this next section we're going to look at is called the Triangle Proportionality theorem. So we're still looking. So yeah, page 631. We are still looking at similar triangles. Okay, but we're going to look at a new relationship here. So I want to make sure we really have, or we don't want to forget the old relationship of matching up corresponding parts, right? Corresponding sides of the triangles. We want to forget that, setting up the ratios and all that stuff here. Here we're going to look at a new kind of ratio relationship that we can set up. Okay. So again, don't forget the old stuff with corresponding parts of the triangles, corresponding sides, and all that stuff. Those still hold. Page 631. Okay. Those old relationships still hold, but now we're also going to be looking at another relationship that is created using parallel lines. So here you can see the essential question we want to be able to answer today is when a line parallel to one side of a triangle intersects the other two sides, how does it divide those sides? And Derek, we are on page 631, okay, so you can catch up here. So, what we're going to look through here, we're not actually going to do this, we're just going to kind of follow along with it, okay? We're not actually going to do the construction ourselves. All right, Josh, I want you to move over here next to Gabe, please. Take your stuff. All right, warned you enough, I feel like, so now it's time to start making some changes here. I would suggest you stay because we're going to be going over a relationship. If you can hold it. If it's an emergency, yeah, you got to go. But if you can wait, I would suggest you wait. You need to write a pass, yeah. Sure. Okay, so back to this, guys. So here we go. So we've got a triangle ABC shown here. All right. And what they ask us to do next is to just select some point on AB and label it E. Again, we're not going to do this. We're just like kind of following with their work here. So they picked this point E right here. Okay? And then they constructed an angle with the vertex E that is congruent to angle B. If you can see here, this is the angle copy construction. Remember that? Okay? You do the arc. You do the swipe here for the arc, you do that same swipe up here, and then you open your compass up to there and do that little swipe, and then swipe from there to there as well, creating congruent angles. Okay? Now, what's going to be true here about EF and BC? They will be what? Not congruent, parallel though. Yes, very good, okay? It does say, yeah, why are, so that's the next question then, why are line EF and segment BC parallel? What did we do here to kind of allow that? What special angle relationship do we have here that makes EF and BC parallel? What's going to be true about these two angles right here? They're corresponding and they're congruent, right? We made them congruent. Didn't we do that? We copied this angle up to there, so they're going to be congruent. I mean, I could put a little, like, congruent angle right there. So they're corresponding. So angle AEF, actually I'm just going to put is congruent to angle ABC. So corresponding angles are congruent. Okay, and that then guarantees that the two lines are parallel. Is it too low or something?
No, I was going to ask
yes.
So if they're in the same position,
exactly right. So actually there's two other pairs of corresponding angles here, aren't there? We have this angle over here, and then this angle over here will then also be corresponding because they're kind of like in a similar position with parallel lines. Remember, you can only have corresponding angles when you have parallel lines here. And since we have parallel lines, then we can say that. So I'm going to go ahead and mark those parallel as well, just so we kind of have that in the picture there. All right. Whoops, are congruent. That shouldn't have an S there. All right, so that's the idea. Now it says here to measure those, so I guess I'm going to try and measure here and see. Oof, I hope this works.
do we need a ruler?
I'll just measure it, and you guys can just copy along with me because I think it's going to be just easier that way, I think. I'll just measure it for us. All right, So let me just measure here real quick. So we'll say, let's see here, that AE, ooh, I'm going to have to turn my paper. I'm going to use centimeters and millimeters here. So let's see AE, I don't like that. We'll say AE is about 8.5, or sorry. Yeah. We'll say it's about 0.8 centimeters there. So AE is about 0.8 centimeters. All right, and we'll say that EB, anyone wants to measure EB? EB is about, actually we'll also say it's about 8, or 0.8 I should say. Okay, so AE is about 0.8, EB is about 0.8, AF, alright, let's see what AF is. AF is, I'm going to say, is about 1.4. And then we'll say that FC is about 1.4 as well.
Oh my God.
Okay? So now it says compare the ratios of AE over EB. So AE over EB is going to be 0.8 over 0.8. Okay? And then AF over FC are the other two, to 1.4 over 1.4. And I've kind of already given away the relationship here.
Do you find the ratios then, right? You do
0.8 divided by 0.8, because AE and EB I both measured to be about 0.8, and that gives us 1, right? And then AF I measured to be about 1.4, FC I measured to be about 1.4, so also, 1, okay? So what's true about these two ratios? They are what? They're equal, or they're congruent, they're the same, that's right. Aha! So now notice here, this relationship is different than all the relationships we've seen so far. We are not matching up. For example, we have two triangles here, right? We have the triangle AEF, we have the triangle ABC. Okay? What do you think we can say about the triangle AEF and triangle ABC?
They're the same.
They're not the same.
Similar.
They are similar, right? Same is congruent. Similar means they're in proportional. So yes, triangle AEF here is similar to triangle ABC. Okay, that is true. So that means, for example, that I could set up the ratio AE over, what does AE correspond to in the bigger triangle? AB, yeah. Okay, and that should equal AF, for example, AF over what? What does AF correspond to AC in the big triangle there? Okay, so like that is something we had before today, but now look at the relationship. We did AE, which is still part, okay, so this was before. Before we said this. Now we can say, though, for example, that AE over EB is going to equal AF over FC. Okay, so this is today what we're going to look at. Notice the difference here. AE over EB. EB is not a full side of a triangle. It's only part of a side. But because we have this parallel line here, that cuts these two parts into proportional pieces with these two pieces here. Okay? So this is different than the one we had before. Before we compared side of a triangle to side of a triangle. Side of a triangle to side of a triangle. Now it's going to be this piece right here that's cut out, and then this piece right here that's cut out. Equals the same ratio as AF over the FC. Okay? So slightly different relationship there. Okay? Yes, Jake.
You know how when you wrote now?
Mm-hmm.
Do we have to write that?
I mean, you don't have to, no, but it's just to kind of compare. This is what we knew how to do before, but now we can say that AE over EB is the same as AF over FC. This parallel line splits these two sides into proportional pieces. AF over FC, AE over EB. They're the same. Okay? All right, any other questions? Let's move on and actually see this in practice. This is a little bit trickier because it's slightly different. Okay? Well, you won't have to actually measure stuff in the future. You'll be given the values and stuff. That's why I didn't have you guys measure it. Okay? So, how can we show that triangle AEF is similar to triangle ABC here? how do we know these two, this AEF is similar to triangle ABC? So we have these two angles congruent. Do we have any other pairs of angles congruent? Part of it, but remember, for similarity statements, we need to say like angle, side, or side, side. So can we come up with, like, we already have one pair of angles congruent. Is there another pair of angles that are congruent in these two triangles? Yeah, so the angle F will be congruent to C for the similar reasoning, and also A is shared by both of them. So, yeah, they're similar by angle.
Wait,
Oh, sorry, I took away the picture there too quick. I just marked those two congruent.
so A is congruent to itself?
Right, because it's shared by both of the triangles. The triangles both overlap on angle A there. Okay, so how can you show that the two triangles are similar? By angle. Okay, I'm not going to explain any more than that because we already drew in the picture there, so that's really all we need. But by angle, the triangles are similar. Okay? All right, we already saw this number 2, but what was true about the ratios AE over AB and AF over AC? These ones down here that we calculated, they were what? They were the same. They were equal. Okay, so these ratios were equal.
Or congruent.
It's a similar concept. Similar concept, but the ratios were equal. Okay. Okay, so we're going to skip number 3 because that leads right into this explain right here. Okay. So basically, this is the triangle proportionality theorem. When you have a side parallel to a third side of your triangle, it cuts. So it splits these two sides here into proportional parts. So AE over EB is equal to AF over FC. They're proportional parts. Okay, and so there's your relationship. So this is a different relationship than what we've been talking about. Part over part equals part over part. Okay, just like that. So we're not going to prove it, so don't worry about that. All right, but that's the relationship. Let's actually get into some problems here. So let's look at, for example, at page 633. Page 633 now. Okay, and see this in action. No, we skipped number 3. We skipped it. Because that was basically what the triangle proportionality theorem is saying. So let's look at number 3. Explain 2, and example 2, find the length of each segment. So in letter A, we're asked to find the length of CY. So that's this side right there. All right. Now, can we use the triangle proportionality theorem here? Well, we have a pair of parallel sides. So this side here is parallel to our third side of our big triangle, so yes, we can use it here. All right? So that means that this parallel line here splits this side into proportional pieces with this side. Okay? So for example, 4 over 9 will then equal, I'm going to call this x. Even though there's like an x there, I'm still going to use x. Okay?
Why 4 over 9?
Because 4 is the kind of part of this full side here that's cut by this parallel side. So
There's 2 shapes in there. YCBX and XYA.
think of it more as a big triangle that has a parallel segment to one of its sides drawn in there. So think of it as a big triangle here with a parallel segment drawn to one of its sides. That's what you should see it as.
Like 4 over 9.
Yep.
Why 4? Like, doesn't matter.
That's the new relationship that we're going to use today. That's the new one we're learning. When you have a segment parallel to one of your sides of your triangle, that parallel segment cuts proportional sides. So 4 over 9 will be in the same ratio as what over what? Anybody? X over 10. Exactly right. In the same relationship. Notice again, I did 4 from the smaller piece over 9 from the bigger piece there. So again, I have to match it up here. X is from the smaller piece, 10 is from the bigger piece. Or you can also think left and right. 4 is to the left of that segment, over the 9 to the right, so x to the left, over 10 to the right. Okay, we cross multiply here then and solve, just like we did before. So 40 equals 9x. So that part's not different. We still do cross multiplication here. We'll still divide both sides by 9. Yeah, we get 4.4 repeating, which is kind of nasty, but that is the correct answer here. Okay, 4.4 repeating. Just because it's a decimal. It's not a nice number. Okay? So there it is, and it's a repeating decimal too. So, any questions so far?
No. Wait.
Okay, so that's the setup there. So now we come down to letter B. Letter B asks us to find Pn. So here's Pn right there. I'm going to call this length here x. Again, we don't know what that length is, so I'll call it x.
Can we call it H?
If you'd like. Whatever variable you want to use is fine. You can use J for Jason if you want to.
Make H because I'm
Okay. And so let's see here. So Taylor, what would be the ratio that we can set up here? So 3 over 2, not quite. It'll be 3 over x, the piece here. Okay, because again, 3 and x share that same side, so we're going to do 3 over x equals, and then what would be the other ratio we can set up there, Taylor? There you go, 2 over 5. Okay?
So it's just a number and on the side.
Correct. All right, and then so we just cross multiply. So 3 times 5, 15. X times 2, 2x.
It's going to be an ugly number.
Divide both sides by 2. It'll be a decimal again. 7.5. Thank you.
It's going to be a nasty number.
All right, thank you, Jason. Okay, so 7.5 is that distance from P to N, using that proportionality theorem there. Okay. Questions on any of that? We're all good? All right, let's try. Let's look at. Oh, some people finish up still. Sorry. You good? Okay. And so then, yeah, x is 7.5. Okay, that's the idea there. Again, the triangle similarity stuff is still at play here too. So I mean, you know, we could also use, you know, the corresponding sides and stuff as well. But this also works because we have parallel sides there. All right, all right. Turn the page, and I would like you all to try 5 and 6 real quick, please. Go ahead and try 5 and 6, please. Okay, give those a shot. All right. So set those up and solve them, please. Number 5 and 6 on the next page there. All right.
Wait, Mr. Wade, come here. Could you tell me if this is right? Guys, okay.
That's one way to do it, yeah. That's like, there's yours, so you can do with them as you please. You're pondering like mysteries and stuff like that. Yeah, all this one. Keep your shortcut words for this one too. Good. It is, Josh, when you pay attention. It's so easy, right? So you're trying to find Rn. So where's Rn? Okay, so let's call that. Let's label that X maybe, so we don't know what it is. Okay. And so, what's the ratio we can set up here? So set up your ratio. So for example, on number 5, you want to find DG. So I want to label DG as X, because we don't know what that is.
Okay. So like, first one, what's
Set up your ratio, Kyle.
So for this, would I do 8 over 5 and 10 over x?
Exactly right. Always the pieces of the same side. Careful when you're it's going to work. It's supposed to work, but it might not always work. So like if you 8 over 5, but I think what you did here is still going to be okay. There are multiple ways to write it, but not every way works. You understand what I'm saying? So you're right, there's like a lot of different ways to do it, but there are a few ways where it will not work, so that's why I like to do it. So, okay, that's fine. Just be consistent, that's all I'll say. Okay, let's call some people here and see what we came up with. So, Chardez, sorry, I called you. Oh, okay, so then Josh, let's have you do the first one then, please. Okay, so that's a great idea. That's what we're trying to solve for, so put that in there to remind us. Okay, yep, and then what? Okay, so 24 over 32 is going to equal what?
Equals x over 40.
Very good, okay.
And you get 32x.
Oof. Yep, equals
960.
960, thank you.
And then you get 30.
Divide both sides by 32, and you got x is 30, you said?
Yeah.
Okay.
I have a question.
Yes.
What if you did, like 32 over 24?
Okay, and then what was your other one you said it equal to?
I did,
So, sorry, so what I mean for number 5, you did 32 over 24 equals
I did
what?
32 over like 40 and then x over whatever.
Okay, so be careful here. So 32 over 40, if you do it that way, then you also have to then say 24 over the x.
Yeah, I did that and I still got the same.
So that will work out, okay? But I would be careful about that. So what Josh was saying, I was talking with Josh and Gabe about this earlier too. There are multiple ways to set these up that will still be correct, okay? But not every combination will be correct, if that makes sense. Okay, so for example, 32 over 40, if you write like this, 32 over 40, and then you write it like x over 24, you see that one will not be correct, right? Because the 32 over the 40, you then put the x over the 24, so that's like not in the right. You see how I'm saying? Like you did left over right, and then you did right over left there, which wouldn't work. But yes, you can set up that way, Zari, and it will still work for the triangle proportionality stuff like that. Okay? My only concern is that, you know, if you just make sure you're consistent then. But I recommend doing 32 over the 24, 40 over the x. You're still right, so I don't want to like say you're wrong there, but I'm going to do it that way every time. I'm not going to like mix it up. Okay? So yeah, Jaden, question?
I got 40.
Okay, what was your setup?
32 over 24 equals 40 over x.
You did 32 over 24? Okay, 32, 24 equals 40 over, you said? Okay, so that's the right setup. So, because when you multiply here, 24 times 40, you should have got 960. 32 times, I both divide 90, divide by 32, and get 30. So I would say, watch your calculations there, okay? All right, question, Kyle, yes.
6 going to be a decimal.
6, maybe a decimal, so let's go to that setup. So, Chardez, back to you now. What's your, Well, okay, so let's still, if you would, please, be brave, and let's do this together, and I promise you'll learn from it, okay? That is right.
And then I put equal to x.
Ah. So we're trying to find Rn here. Now, look what you said, Chardez. Let me show you. You said 8 over 5. So you did like the left piece over the right piece, left over right. Then you said equals right over left. You see what the issue here? So it should be 8 over 5 equals what, Chardez? You got it. There it is. Okay, and that's the key thing, is we want to make sure we set it up in the correct order. Okay, same order. So we cross multiply here. We get 50 equals 8x. Divide both sides by 8. 50 divided by 8 is 6.25. Okay? So yes, it is a decimal there. Okay, questions on any of that? Questions on any of that? 6.25 is the answer. All right, so we're going to skip the next explain because, again, it's another proof. But basically the idea is this. We can also go in the reverse order. So, for example, here we use the fact that these two things were parallel to then set up these relationships. Okay, she said 8 over, like what Chardez says, 8 over 5 equals 10 over x. We were able to solve for x. If we don't know these two sides are parallel, we can prove them. We can show them to be parallel using those ratios. If the ratios are equal, then we can say that the two sides are parallel. That's what this next piece is we're going to look at. Okay, so let me skip on to that. So if you want to turn to page 635, we're going to look at this one, and okay. 635, we're going to look at A and B, and then we'll stop, and I'll give you guys time to start on your homework, okay? So, So this one's different in that you can see we're not going to solve for a missed side here. The example 4 says to verify that the line segments are parallel. That is, we want to show that MN is parallel to KL here. Okay? They're the only ones that are possible. So how can we do that? Well, we're going to set up the ratios that should work. Okay? So, and what I mean by that is, all right, so Xander, for example, to set up my ratio here for this side, I should put 21 over what? 42. And I'll put it right here. And we want to know, does that equal, and then what's the other side ratios here, Xander, I can set up? You got it. Okay. Remember, we have a couple different strategies here to determine if these two ratios are the same. Some people like to cross multiply. Some people like to just do the division and get the decimals. Okay, I'm going to do just the division in this case. 21 divided by 42 is 1/2. 15 divided by 30 is also 1/2.
Also, they are.
So does 1/2 equal 1/2? Yes. So are these two segments parallel?
Yes.
Yes. So they are parallel.
What is it?
And that's it.
What if you were to do it the other way?
Okay, give me the other way that you want to try it there, Jaden. Sorry?
Wait.
Oh, you want to cross multiply. I see what you're saying. Okay. 21 times 30 gives us, so if we do it that way, 21 times 30 is 630. 42 then times 15, right, Jaden, is the other one? 630. So they are equal. Now, they're going to be different numbers. That's okay. We just want to say that they're equal. That's all. So they are, so it's parallel. Okay? Great question. Thanks for asking that. All right. All right, letter B. Now let's get this one. We want to show that DE is parallel to AB, but notice here we are missing side AD and side BE, so we can't set up our ratios like we want to. Okay? Are we given any other information here in this problem?
Yes.
Yeah, AC is 36, so the whole length here is 36.
All right, so then you take...
Hang on, hold on a second. And then BC is 27. Let me just finish that, Jason, and then I'll let you kind of roll with it here. Hang on. Okay, now what, Jason? Sorry, go ahead.
All right, so you do 36 minus 20.
36 take away 20, that will give us what length? 16. And that's 16 is the AD there. So I'm going to write that up here. 36 take away the 20 gives us the 16. And then what else do we need to do here, Jason?
And then 27 minus 15.
Very good, that's right. Equals 12, so that is 12. So are we done now? That's the answer. I mean, oh right, we still have to set up our ratios, right? Okay, so 16 over 20 is right. That's one way you can set it up. And we want to know if that equals what? 12 over 15. Okay. So there's our, sorry, I'm off the screen there. So there's our ratio now. Okay, so it's a little bit of preliminary work, and that's something you guys need to be looking out for. Jason saw it. Great job there, Jason. Okay, and some of you guys, some of the other guys probably saw it too. Just didn't say anything. Okay. Sometimes you got to do some preliminary work. All right, question, Josh. Yeah, sure, go for it. So what do we do now?
16 times 15.
Okay, 16 times 15 is 240.
And then 20 times 12 is 40.
It is. So is DE parallel to AB? Yeah. They are parallel. Okay. They are parallel by the Triangle Proportionality theorem. Okay. Okay. So that's it. Those are the two kind of problems you're going to be tackling tonight. Okay. So let me give you guys your assignment then. Okay. Let me give you your assignment then. Here, if you want to have this look at. Okay. So we're going to start with 3, 4, 5, 6, 7, 8, 9, 10. Okay, now, I want to point something out here. 6, 7, and 8 do not have the directions for you on the paper. I think there's a typo. Okay? So your directions here for 6, 7, and 8 are to determine if the given segments are parallel. That is what you're supposed to do there. They don't have the directions for you, but that is the directions for 6, 7, and 8.
Oh, we don't want to do that. What page?
No, don't worry about 1 and 2. Sorry, page 637. Page 637. Please copy down those directions for 3, 4, 5, and for 4, 5, and 6. Or sorry, 6, 7, and 8. Goodness. Okay. So page
Wait, you crossed out
637. Yeah, I didn't mean to though. I'm sorry. I do actually do number 6. You can do it. I crossed out initially because I was like, wait a minute, that doesn't make sense for what you're being asked. But then I realized the directions were missing. So please actually do number
So we're just doing 1 through 8?
3, well, I do want you to do 3 through 10. 3 through 10 there. Okay. And then, hang on a second, I think I did have one more I wanted you to try. Yeah, I'm going to have you try number 16 on page 639 as well. Okay. So there they are. Okay. Oh, and number 7, it should be OR, not QR. OR, not QR.
You know, they really need to have higher answer.
Yeah, this is the problem when you make a new book, is that eventually there are mistakes, or there are always mistakes in the new books. Okay?